Have you ever wondered how scientists prove that light always follows a predictable path? Today, we're building an amazing reflection apparatus that lets you observe the law of reflection with incredible accuracy. The best part? It's made mostly from recycled cardboard. Let's build it step by step. To make this project environmentally friendly, we're using recycled cardboard instead of expensive materials. Start by cutting 4 pieces measuring 30 by 4 centimeters and 4 pieces measuring 11 by 4 centimeters. On one of the smaller pieces, make 2 holes exactly as shown in the video. These holes will hold the laser pointer securely. Now glue all of the pieces together using white glue. Take your time and make sure every edge lines up perfectly. A strong, square base is the foundation of an accurate scientific instrument. Place the piece with the holes on top. Allow the glue to dry completely before moving on. Next, cut the remaining cardboard pieces according to the dimensions shown in the video. Using quick setting glue, assemble them carefully to create the main body of the apparatus. Now it's time to build the rotating laser arm. Draw a center line along the entire arm. Measure 4 centimeters from one end and make a 3 millimeter hole directly on the center line. Next, move to the semicircular section of the main body. Then make another hole precisely at the center. Now insert a 1-inch screw through the center hole and secure it permanently with quick setting glue. Once it's fixed, attach the laser arm to the main body using a nut. Don't tighten the nut too much. The arm should rotate smoothly without any wobbling. This smooth movement allows us to measure different angles with excellent precision. Now we can install the most important part of the entire apparatus, the mirror. Position the mirror so it is perfectly vertical. Even a tiny tilt can change the path of the reflected light and affect the accuracy of your measurements. To strengthen the front section, we're adding 2 extra cardboard supports. Next, we'll cover the apparatus using a 100 micron A4 OHP transparency sheet. Secure it neatly with clear tape. Besides giving the setup a clean, professional appearance, the enclosure traps smoke inside the apparatus, allowing the laser beam to become visible through the scattering of light. Now let's make the measurement scale. Using an A4 sheet of colored paper, draw 2 parallel lines that are 1.5 centimeters apart. Next, use a compass to draw 2 semicircles with radii of 12 centimeters and 13.5 centimeters. Using a protractor, carefully mark every angle from 0 degrees to 90 degrees on both sides. These markings will allow us to measure the angles of incidence and reflection accurately. Mark the exact center point because this will align with the pivot of the rotating arm. Now carefully cut along the curved outline with a craft knife. Finally, glue the completed scale onto the apparatus using white glue. Take your time to align it perfectly. Accurate markings lead to accurate scientific measurements. Now it's time to install the laser pointer. Insert the laser into the 2 mounting holes on the laser arm. A properly aligned laser beam is essential for accurate observations. During the daytime, a laser beam is often difficult to see because the light travels through clean air. That's why we've made a small 6 millimeter opening on the side of the apparatus. Using an incense stick, gently introduce a small amount of smoke through the opening. Now the experiment becomes much more exciting because you can actually watch the light travel to the mirror and reflect back. It's a fantastic way to visualize one of the most important principles of physics. Congratulations! You've successfully built a fully functional reflection apparatus using simple materials and a little creativity. This project is perfect for STEM classrooms, science fairs, and hands-on physics learning.
If you enjoyed this project, be sure to like, subscribe, and turn on notifications so you never miss our next STEM adventure.